Welcome to this project walkthrough on handwritten digit recognition using PyTorch CNN and Flask. In this video, we will explore how the system works, how the model is trained, and how the web application predicts handwritten digits in real time. Handwritten digit recognition is a classic machine learning problem used in real-world applications such as postal automation, banking systems, and digital form processing. The goal is to automatically identify digits from 0 to 9. This project builds a deep learning model using a convolutional neural network, or CNN, and deploys it using a Flask web application. The system allows users to draw any digit inside a browser window, and it instantly predicts the number, shows the probability distribution, and displays interpretability feature maps extracted from the CNN layers. The model is trained on the famous MNIST dataset, which contains 60,000 training images and 10,000 testing images of handwritten digits. Each image is 28 by 28 pixels, grayscale, and centered. MNIST is still one of the most widely used datasets for benchmarking deep learning models. The model architecture consists of two convolutional blocks followed by activation, pooling, and dropout layers. These layers automatically learn patterns such as strokes, edges, loops, and shapes found in handwritten digits. Finally, the flattened output passes through fully connected layers, and a softmax classifier predicts the digit class. This architecture achieves more than 99% accuracy on the MNIST dataset. The training pipeline includes data pre-processing, normalization, train validation splitting, forward and backward propagation, and parameter optimization using stochastic gradient descent. A cyclical learning rate scheduler enhances stability and convergence. The final trained model is saved as a PyTorch checkpoint file and used during inference. The Flask backend loads the trained CNN model and handles image submissions from the front end. The image drawn on the canvas is converted to a base 64 string, decoded, resized to 28 by 28 pixels, normalized, and converted into a PyTorch tensor. Flask then generates predictions, probability graphs, and interpretability heat maps, and sends them back to the browser. The user interface is built using HTML, CSS, and JavaScript. Users can draw digits with their mouse or touch input, submit the drawing using the Predict button, and instantly see results. The interface also offers a clear button to reset the canvas. Probability charts and interpretability maps appear dynamically after each prediction. An important highlight of this project is model interpretability. PyTorch forward hooks extract feature maps from each convolutional layer. These maps visualize how the CNN views the digit through different filters, helping users understand why the model predicted a certain number. To summarize, the user draws a digit, the browser sends the image to Flask, Flask pre-processes it, and sends it to the model. The model predicts the digit and generates interpretability data, and the browser displays everything beautifully in real time. The project uses PyTorch for deep learning, Flask for deployment, HTML, CSS, and JavaScript for the user interface, and Matplotlib for visualizing probability distributions and interpretability results. This project is ideal for students learning deep learning, full-stack AI deployment, and real-time computer vision applications. With more than 99% accuracy and a clean user interface, it is a powerful end-to-end AI demonstration.